Okay. All right, we're live streaming on YouTube. Hi, everybody, and welcome back. It's nice to see everyone again. It's been a while since we've been here. Just a reminder before we get started, as per usual, that if you're joining us on Zoom, don't forget to change your little all panelists bar in the chat. So if you take a look in the chat, it'll say all panelists. Just switch that to all panelists and attendees if you want to talk to everybody. And hello, everyone. So today is one of my favorite sessions. I'm really excited for today. Chris, we're going to talk about sci-fi today, right?
Yes, we are. And the challenge of this is that there's so many directions we could go that I didn't prepare too formally. I just came prepared with some links and some things we can kick it off with. But I'm keen to hear from the audience, to hear from you. If you wouldn't mind, I'd like to give a little preview of what's going to happen in the sky for the next week or two, if we want to start off with that.
Sure, let's start with that. And then while Chris is giving us a little bit of a preview of what's happening in the sky in the next week, let us know what your favorite sci-fi canon is, I guess is the word. I keep saying like TV/book, but what I'm looking for your favorite, like if it's Star Trek or if it's Star Wars or Firefly, which is where I go to.
Could be video games.
Yep, true.
Anything, yeah.
So have a think. Oh, The Expanse, yes. I love The Expanse. Anyway, sorry, yes, we're going to talk about what's happening first this week. What's up in the sky, Chris?
All right, so just let me start up Stellarium here so I can give a preview. There's some cool things happening. So let me just get this up.
Not to worry. Space 1999, Deep Space Nine, Star Trek, Firefly. Ooh, Vorkosigan Saga. I have not.
Yeah. I'm going to talk about that.
Okay.
Going to talk about that. Yeah.
For those of you, someone just mentioned 2001: A Space Odyssey, and for a while I used to work at the Science Center, and for a while the Science Center had a space and sci-fi types exhibit, and they had a replica of HAL, and it was the creepiest thing when you were walking through there at night because it would talk randomly as you walked by.
Oh wow.
Yeah. Okay.
Right. So what I'm going to do is I'm just going to run through some of the events that are coming up that people might want to be mindful of, and maybe head outside. You know, grab your eyeballs and head out, or grab your binoculars, or if you have a telescope, dust it off. You definitely want to get that telescope ready to go for the summer and fall, because it's going to be planet season. And already I'm really excited because down here in the bottom stellar, you can see the word Jupiter, and that's indicating that Jupiter and Saturn are rising at a not too bad time, 10 p.m. or so. So by 11 o'clock, if you head outside and you've got, a view of the southeast horizon, you can pick up Jupiter and Saturn. Jupiter has a really bright dot, and then Saturn is a dimmer dot sitting to its lower left. And what's really neat is Pluto. So Pluto is not observable by folks with general commercial telescopes or amateur telescopes. Magnitude plus 14, which is really super faint. But for the next couple of nights, Jupiter is going to be passing less than a finger's width above Pluto. Let me see this up here. So suddenly a moon diameter, 35 arcs, so it's at arm's length. So if you gaze at the sky at Jupiter, you'll know that Pluto is right below it. If you want to grab your telescope, most telescopes' field of view will show, actually, this is Stellarium version 0.20.2, and has a new cool feature called field of view indicator. Let me just open up markings, and there's a circular field of view. And I can dial up a nice circle that shows roughly what a telescope would show.
Cool.
So that's a new feature that's in Stellarium. Yeah. Now there aren't any bright stars in the neighborhood of Pluto that'll let you sort of pick it off that way. But so this is the 30th. So this is tonight, 11 o'clock. And let me just go back. And what I'm going to do is I'm going to center off the star. I'm going to center that. And then I'm going to advance to tomorrow. And you can see that both Pluto and Jupiter are heading to the right because they're both moving in retrograde motion right now. Saturn actually passes Pluto by.
Oh, cool.
So there's something you might want to do over the next couple nights is take a look at Jupiter magnified and just know that Pluto's there.
So what kind of telescope are we thinking about if you wanted to observe Pluto?
So your best bet to see Pluto is to take a photograph, or if you've got a big aperture telescope, 10, 12 inches, you might be able to sort of sketch the dots, sketch the stars, and come back a night or two later and see which one has shifted position, and that would be Pluto. But one of the best ways of seeing Pluto is to take some photos of the sky, maybe on a few different nights, and see what moved. Every now and again, Pluto will actually pass close to, a reasonably bright star like this one over here, which is pretty easy to pick off in binoculars. And sometimes you can sort of see readily the dot move with respect to that more brighter star from time to time. But at the moment, unfortunately, Pluto isn't sitting. Let me see if I can pick Pluto itself. I'll center Pluto and see if it's going to come in the vicinity of anything. So here's the next little while. Yeah, so there really isn't anything over the next few weeks that are optimal for picking it up. The other thing is that Pluto and Jupiter are getting close to their opposition points. And that's the point of the year where Earth is passing them on the inside track around the sun. And that means that we're at our minimum distance from those planets. And so they will appear at their brightest. They'll look largest in the telescopes and things like that. And because, as I pull out here, you can see that Saturn is in the same neighborhood. So Pluto and Jupiter are having opposition on, see if I can pick that up. It's coming up this month. They're on the 14th of July, and then Pluto is the night after, the 15th of July.
Oh, okay. And then I think Jupiter's the 20th, right?
Yeah,
no,
and then Saturn is on the 20th.
Yeah.
But some people have the misconception that if they miss seeing the planet on that night, that they've missed their opportunity. But really the difference from night to night is not that great. So if it's cloudy that night, you can even start a week ahead or pick it up a week after. No harm, no foul. You can still see the planet at its best. So we got that event coming up. The other one thing I wanted to point out was the moon, and I highlighted this in my skylights the other day. So let's see if I can pick up a picture. So if you can see that, this is the Mare Imbrium. This big gray area is called Mare Imbrium. And this little bay on the side of it is called Sinus Iridum, which is the Bay of Rainbows. And when the moon is at the phase where it's only about this full, so let me see if I can go back and pick that up so you can see that. Pick up the moon and center it, go back a day. So around Thursday night or so, the terminator of the moon, that's the line that divides the lit and the dark sides, the dark hemispheres of the moon, will be just sitting beyond Sinus Iridum. And that will cause, there's a range of mountains, which is formerly the edge of the impact crater that produced the Bay of Rainbows. And that gets nicely illuminated at this phase of the moon. So it almost creates an effect like a golden handle. Not that it's the color gold, but people talk poetically about it as if it's sort of a handle on the edge of Mare Imbrium. So Thursday night, if you think of it, if your skies are clear, head out, get your binoculars, take a look at the moon, and pick up the handle on the edge of the big mare on that night. And if you miss it, it's back next month. It happens every month around this phase.
This is the
Just
joy
a
of
few
observing
nights
the moon.
or full moon.
Yeah.
All right.
Perfect.
Now the next one I wanted to talk about is back to Jupiter here for a second. And by, if anybody has any questions on any of this, just let me know. And
So far, all good. I just wanted, for anyone who's curious about stellarium and what we're using to look at all this stuff, I just sent the link to the episode, our very first episode of the Insider's Guide to the Galaxy, when it was still called Homebound Astronomy, which will show you how to use stellarium if you're curious.
All right, now, so let's see if I've got this right. Yeah, so late on Thursday evening, you're going to see Jupiter, as I said, sitting over the southeastern horizon. And if you have a good telescope and you want to point it at Jupiter, you might pick up the little black spot, which is caused by the moon Ganymede casting its shadow on Jupiter's face. And that will take a couple of hours, about 3 hours, to cross the planet. But the cool thing is that you've got the great red spot accompanying it at the same time. Now, you don't need a huge telescope to see the great red spot, and pretty much any backyard telescope will see Jupiter's equatorial bands. So it's worth a look at any time and give it a try. So this would be, the black dot will basically be visible starting around, once it gets away from the edge of the planet. So around 10:30 p.m. and that'll run across, and I'll just jump ahead a couple hours here. This is around midnight. Now, generally speaking, it's hard to see the moon itself. So you'll see the black shadow and you'll be seeing a shadow. Don't be thinking you're seeing the moon, because the moon is sort of a light color and it sort of fades into the background of Jupiter's disk. But if you have a very good telescope, you can certainly see both the spot, the shadow, and the moon itself that's casting the shadow at the same time. So this is about 1 a.m. on, so that would be Thursday, yeah, on the 3rd. Okay. And that'll last, another hour or so. So you've got a big window of opportunity of a few hours to see that if you want to give it a try. These so-called shadow transits, they're relatively common. What's really cool is occasionally we get 2 at once or 3 at once when they line up just right. I don't think there are any of those in the offing at the moment, but as we continue the series, if I see any, I'll be sure to point it out to folks.
There are some later in the summer, and I only checked because you had brought my attention to them, and they're so cool. Yeah.
On Saturday, we have the Earth at aphelion. So we have the Earth reaching its farthest distance from the sun for the year. So obviously the summer heat is not produced by our proximity to the sun. It's produced by the tilt of our axis of rotation and how much solar radiation that the northern hemisphere is exposed to in a given day. The days are longer because of that, and that gives us more solar radiation and warmer temperatures. And the Earth's perihelion occurs 6 months later. That's in January. So the day of the year when we're closest to the sun is in the early January, right after New Year's.
That's one of those common misconceptions for people, where people assume that since we're closer to the sun, it should be warmer, and it's not the case. It all depends more on the tilt.
Well, there is a theory that the southern hemisphere summers are hotter than they should be because they're both summertime and closer.
Okay.
So they do get a bit of a cumulative effect, but but the weather and the climate that we get is not particularly related to our distance from the sun. All right, so on Sunday we have the full moon, and I think I can get the markings on here for the Earth's shadow. Let me just get those set up here.
Oh, right, we have
we have an eclipse.
An eclipse, yeah.
Let's see if I've got the, oh, I think that's under solar system.
Let's see.
Oh, maybe it's under markings.
Would it be, no.
Well, put on the anti-solar point.
Okay. That's the exact opposite side of the sky from the sun, right?
Yeah, the anti-solar point is the opposite from the sun.
So which should give us, right, yeah.
Let's just run through here. So the full moon occurs on the 5th at 12:44 a.m. So let's just advance up to the 5th and we'll go to the 0. So there's the anti-solar point. So that's why the moon is full, because it's opposite the sun in the sky. And if the moon is close enough to the ecliptic line, then we get an eclipse, a lunar eclipse, when the moon dips into the Earth's shadow. Now, there is actually a penumbral eclipse happening that night. And I can't seem to find the circle, but the Earth is casting a shadow opposite the sun in the sky into space. And any satellite, any spacecraft that passes over the moon that passes inside that shadow gets reduced sunlight on it and then darkens. And so at this full moon, the shadow is just big enough that it contacts the northern section of the moon. And so we're producing, it's called a penumbral eclipse, because even the part that's in the shadow will still have some sunlight exposed to it, as opposed to when it's when the sun is completely hidden by the Earth. So the top part of the moon will darken slightly. It'll be very difficult to see, very subtle, but it will be happening. And it's the first eclipse of any kind visible in the Western Hemisphere this year. So,
do you know if we're getting anything besides penumbral eclipses? I thought this year was kind of not a very fun year for eclipses, eh?
Let's see, let me just open up my list of eclipses here.
There's also, if you're curious about information like this, timeanddate.com is a really good place to look for it. That's usually where we find stuff like this. Or the Observer's Handbook.
Yeah. So yeah, penumbral eclipse on the 5th. We have an annular solar eclipse on the 20th. No, that's last month. Sorry, we want to go ahead. Yeah, July 5th, the penumbral eclipse. November 30th, we have another penumbral eclipse of the moon, lunar eclipse. And then there's a total solar eclipse on December 14th that's visible down in Argentina.
Okay. Not a whole lot going on that front.
Not this year, no.
Yeah.
All right, so that's the moon and the eclipse. And then what you want to look for is the following night. Let me just get rid of this, come back. So this is late evening on the 5th, which is Sunday night. And you're going to see the moon make a really neat little pretty triangle with Jupiter and Saturn. Let me just change the size of the moon here so it's not so enlarged. So there's the true size of the moon with Saturn and Jupiter. Oh. And that'll make a really cool photo if you compose it with some interesting scenery.
True. That would be a nice one. It's right around sort of closer to sunset, but I guess you'd see in the morning too as well.
Well, they're together all night, so
Perfect.
you can pick them up and you can catch them before dawn. The triangle won't be as nice.
Yeah, true. Mm-hmm. Trying to think of things close to the horizons that you can get scale with the photo.
Yeah, but a city skyline or some buildings or trees or something would be great. Here's the next great one. So now Venus was in our evening sky for months and months, and now it's jumped into the morning sky. Let me just bring up the pre-dawn morning sky here and find Venus. There's Venus. Oh, yeah. What Venus is going to do, so let's get back to tonight. Here we are tomorrow morning, Canada Day morning. Happy Canada Day, everybody. So what Venus is going to do is its orbital motion is going to drive it right across the face of Taurus the Bull. So if you happen to be up, just get a few more stars here. I know 4:30 is not human time for many people, but yeah. But for those that are keen, so here's what Venus is going to do over the next week or so. This is Canada Day morning. Then the next one, and so on. So by the 10th, 11th, it'll be sitting close to this bright star Aldebaran, which is the sort of the eye of the bull, and then it'll leave the face of the bull. So that'll I could also make a neat photo op if you can get the right combination of dark sky. Venus is going to overwhelm to a great extent the other stars in to your naked eyes or maybe to a smartphone photo, but in binoculars you'd certainly see the other stars around it.
Mm-hmm. That'd be a nice view with binoculars.
Let's see if there's anything else. And then on July 10th, Venus is going to reach its brightest for the morning apparition. So it's just going to continue to ramp up, and it'll be about magnitude, what have I got here, minus 4.47, which is really bright. So that's a preview of the next almost 2 weeks. I think that's the main, those are the main events that I would like to highlight over that period. Any questions on that before we?
So far, there might be one. Oh, nope, it's just for me. For the video about Stellarium, I'll send I'm pretty sure that's the right link. I think it's still copied. So the link for Stellarium, the how to use Stellarium is in the chat, and it's also now an answer in the Q&A on Dave's question. Other than that, we don't have any questions about the sky in the next 2 weeks. Thank you for letting us know what's going on. I wish I was better at getting up in the mornings to see Venus. It's so hard sometimes to haul yourself out of bed at 3 a.m. to get ready to go and see Venus.
Well, let's say that for the viewers that have to get up early for other reasons, this could add a little bit of cream in their coffee, something to.
That's lovely.
Look
That
out
sounds
for.
good.
Yeah. All right. So, getting back to the topic of the day, as I said at the start, this is a crazy topic. We could go in lots of different directions. What I thought I'd do is kick things off a little bit with some Star Trek references, because we talked about the planet Vulcan in our write-up. And so let me just get my Zoom toolbar out of my way of my notes here. So I can actually send you, let's see if I can send you a couple of links. Anyway, I'll take care of that in a little bit, but I have a couple of links to some really cool web pages that list all the Star Trek episodes from the different series and the stars and planets that are referenced in those episodes. So one of the first things to talk about is how we refer to stars and planets versus how they did. So astronomers, we have proper names for stars like Altair and Betelgeuse and Rigel. But most of those stars also have a Bayer designation, which is the Greek letter in the alphabet plus the constellation names. So, Rigel would be Beta Orionis, or Antares here would be Alpha Scorpii. So it had more than one name. But in Star Trek, they did a similar thing, but they flipped it around and they changed it. So in our case, we name our stars that way. When we talk about exoplanets, what we do is we take the star name and then we add a letter. So we call the star the A, and the first exoplanet we discover around it would be B. And we go C, D, E, F, and so on. So if I were to talk about 51 Pegasi B, then it would be the first exoplanet discovered orbiting the star 51 Pegasi. And we're going to talk about 51 Pegasi in a little bit. Whereas in Star Trek, they flip it around. So they would call it Talos 4 or Rigel 7. And that would be the 7th planet orbiting the star Rigel. And so if you watch Wrath of Khan, and I recommend you do that on a regular basis, Wrath of Khan, Kirk maroons Khan and his troop on, they call it, I think it's Chekhov says Seti Alpha. He'll say, you marooned us on Seti Alpha 3 or something like that. And there was a disaster, and they ended up, barely surviving. But so when they say Seti Alpha, they're talking about the first planet around the Seti star, or they're talking about Alpha Ceti, planet number 1, planet number 2, planet number 3, etc. So it's a little bit different. So let's see. I wanted to talk about So Alpha Ceti, which is also named Menkar, was where Khan was marooned, and that star is a spring star, so a winter and spring star. So let's go back a couple of months and see if we can pick that star up to show people where it is. So Seti comes from the constellation Cetus, the whale.
Oh.
Just go back a few hours here. So if you get up in the evening, so the early evening in February, you're going to pick up the constellation of Cetus or Cetus, I'm not sure. And the star Menkar is the brightest star in the constellation. So that's the star where Khan was marooned. The planet was orbiting that star.
Oh. Yeah. And now, sorry, this is a bit of a divergence just in general, but in Star Trek, is it the same? Are they in the same galaxy as we are? Or did they take names and just put them on other stars? Is it meant to be the same stars?
No, I mean, I'm not a deep Star Trek nerd, and I'm sure if we have any viewers who are, they'll be correcting us.
Phil jumped in and said, yes, it's
right
the same
and left.
galaxy.
But you might have heard Alpha Quadrant, Beta Quadrant, Delta Quadrant, and so on in Star Trek. And they're basically taking our Milky Way galaxy, which is a big flat disk, and they're dividing it into sectors.
Okay.
So they're staying within our home galaxy. They don't. There may have been episodes where Q sent them extra galactic, but for the most part, the Star Trek universe stays within the galaxy because.
Cool. Okay.
Yeah. So there's there's Menkar. Now the star that's the home star for the planet Vulcan is Omicron Eridani. And this Eridani is the constellation of the river. So here's Eridani. It's a really long, winding constellation. Let's see if I can go back and bring up more of it. Let's go back. There we go. It sort of hugs the disappears below the southern horizon for us at the 43rd parallel. But the star we want is Omicron Eridani. And it's right there. I'll just zoom in on it. Okay. Oh, it's actually, this is the one we want. So Omicron Eridani is a double star. It's these two, Beta and Cade. And it's Cade that's the one that's planet Vulcan orbits around.
Oh.
And this star is a magnitude 4.4. So it's visible to the unaided eye or certainly in binoculars and telescopes. Let's see, it's visible from October through March. So by the end of the summer, heading into the fall, we can remind folks that if they want to head out, they can take a look. And I did read somewhere today that somebody theorized that the Andorian race also were on a planet orbiting the same star.
Okay.
So I don't know if anybody wants to gainsay that or disagree with that, but that was a theory I heard.
Interesting. We've also had two people now, Gord and Dwayne mentioned. First of all, Dwayne is from Vulcan, Alberta, which I did not know existed until just now. And then Gord mentioned that it's about an hour drive southeast of Calgary for anybody who wants to see Vulcan that's a little bit closer.
Excellent. Yes. To drive to Cade would take thousands of years, right? So let's go back and highlight some of the stars that are available at this time of the year that have Star Trek connections. All right, so let's go down. And
this is fascinating. So I have never watched Star Trek. My dad loves it, and I've just never gotten into it. I've watched a couple episodes with, I don't know if I should say Data or Data. I think it's Data, right?
I say Data.
Okay, is that what's said on the show?
Patata.
I've watched a few episodes though, but it's interesting because my go-to sci-fi series is Firefly. And it's not based around the same star systems. They've like made up a new star system essentially. So it's neat to see one that is based on our actual star system.
I think Firefly, a good candidate system for Firefly would be TRAPPIST-1.
Oh yeah, that could work because it's like one with lots and lots of planets around it, and
it's got
stars. Yeah,
3 at least Earth-type planets in the system, with lots more real estate to play with.
That's true.
So maybe. All right, so let's talk about a little bit more about Star Trek. So Antares, which is the brightest star in Scorpius, it's visible as soon as it gets dark. I mean, it's visible all summer long, right over the southern horizon. You can look for the 3 little white stars forming the claws of the scorpion, and the double star marking its stinger. That's a little bit lower. So Antares was the subject of the original series episode Charlie X, Trouble with Tribbles, Piece of the Action, In Truth There Is No Beauty, and then in TNG, Ensign Rowe, and then Face of the Enemy. And in Voyager, Message in a Bottle, and in Enterprise, The Breach. All those episodes referenced Antares in some way. Then heading out in the southeast, we have our summer triangle of Deneb, Vega, and Altair. Altair here was Amok time, Wrath of Khan was mentioned, Altair was mentioned in Wrath of Khan. Deep Space Nine episodes, Profit Motive, and You Are Cordially Invited. So that's Altair. And then we have Deneb. Deneb was mentioned in Where No Man Has Gone Before and Wolf in the Fold episodes. And let's see, the TNG episode Conspiracy. And again, I don't have a Star Trek brain, so I don't know exactly, I can't picture these or summon pictures of all these episodes in my head, but I'm just giving people a little taste. And finally, Vega. So Vega was The Cage, the original series pilot, The Cage, Mirror Mirror, and then in Voyager, Child's Play, The Haunting of Deck 12, and in Enterprise episodes, Broken Bow, Future Tense, and Twilight.
Wow.
So those are cool. Star Trek connected. And I can share a link to a page that has dozens more that are listed.
Okay, that's very cool.
But I picked these ones because folks can go out on the next clear evening and see those stars for themselves. So Scorpius, Antares, Vega, Deneb, and Altair.
That's very cool. And Phil, who is the executive director, chimed in. He hasn't, Phil, if you want to talk to everybody, you got to change it from all panelists to all panelists and attendees. But mentioned that according to Memory Alpha, the home world of the Andorians is the Procyon system. And I understood exactly Procyon out of the entire thing of that sentence. I'm sorry.
I think what I was seeing is perhaps a Redditor that was postulating a contrarian opinion. So Procyon is a winter star. It's winter and spring. So we can go there if we have time later.
Next time. And also a mention as well. There was a question from James saying, what is the likelihood of any of these mentioned stars having habitable planets?
Oh, well, many of them do. In this app, I don't think I can show, can I show the exoplanets?
I don't think it.
They're the exoplanets. Wow, yeah,
there we go. Those are the ones that we know of.
Those are the ones that we know of as of now. But I actually have some notes coming up where we get into a bit more about exoplanets.
Sounds good. And just a mention to that that giant grid.
Yeah,
pattern,
that giant patch.
That's where
Kepler.
Yeah, that's where Kepler pointed, and Kepler found a bunch of exoplanets. So just looking in that one part of the sky, if you look at that and extrapolate into the rest of the sky, the odds of the other stars out there having planets are also pretty darn high.
Yeah, so it's a observational bias. We only looked here, so we found many. Yeah, several thousand in that patch. All right, now we'll come back to Vega because Vega's interesting in another couple of different ways. So I thought we'd switch to Star Wars for a second here, and people wondered, it's a galaxy far, far away. So what galaxy is it?
Ooh.
Do we know? Do we know what galaxy it is? So I did have somebody suggest that it might be the Triangulum Galaxy, which is Messier 33. So let's see if we can find M33. So the Triangulum Galaxy rises in late evening, about midnight. So if you stay up later, or if you wait a month, it'll be a little bit higher. So this diamond shape is the distinctive diamond shape of the constellation Pegasus. It's very distinctive when you see it in the sky. And the Andromeda Galaxy is right above it. We'll come back to that in a second. The Triangulum Galaxy is big. Here it is here. So it's a not quite face-on, but it's close to face-on spiral galaxy. It's located about 2.7 million light years from our sun. And even though it's very, very large, its actual size is more than 2 full moon diameters across. But because it's sort of face on, it's very distributed, its light is spread out over a large area. And so it has what we call low surface brightness. So it's not that easy to see it, even with binoculars. If you have a nice dark sky and binoculars, you can pick it up with binoculars as a large fuzzy patch. And where it is, if you want to see it for yourself, is to look for the diamond of Pegasus, the square of Pegasus, and come on down to the east, sort of lower left, and look for this triangle. It's a very obvious triangle-shaped constellation called Triangulum, and it's kind of sitting just to the northwest, or just a little bit to the upper right of the tip of the triangle. So that's one theory. Now, either in the novel ET, or I'm not sure where it was, but somebody had written that ET mentioned that he was 2.5 million light years from home. And so what's 2.5 million light years from Earth? The Andromeda Galaxy. So it's possible that ET is from the Andromeda Galaxy, which is pretty good for space travel. So that's a possibility. So the Andromeda Galaxy is really easy to see from the cottage, from a dark sky when the moon's not around. Pick up your binoculars. When you're done searching for the Triangulum Galaxy, let me just bring on the labels here. Then scoot on up and take a look for M33. So M31, the Andromeda Galaxy, it's actually 6 full moons across by about 2.
Wow.
So that would be about 3 finger widths held at arm's length by about 1 finger width. So it's quite a big oval. Wow. So that's really easy to see during the summertime. So late evening now, or after midnight now, or you can wait till July, August, and it's much easier. And speaking of ET, let's go to NGC 457.
Hey, nice.
Which is sitting here near the W of Cassiopeia. And we'll zoom in on that. And you can see this little guy. I'm going to turn off the symbol. And I'm going to flip this around. And let me just turn off the stars for a second here. There we go. So there's the ET cluster. These are the 2 eyes. Here's his body, sprinkle of stars. Here's his feet. And then he's got 2 arms stretching up on either side. And some people think that one of these stars would be his fingertip glowing.
Oh, cute.
So it could be the owl cluster, the dragonfly cluster, or the ET cluster.
I like ET the best.
And it's actually NGC 457 is the name of the cluster. And that's located, the easy way to find that is to start at the top of Cassiopeia and count down 1 star, and then use this star and the next one to make a right angle triangle.
Okay, yeah.
And the cluster sits right at the 90-degree corner of that right angle triangle.
Okay.
All right.
This is.
I flipped it. Let me just put it back.
Okay.
There we go. Yeah. So there's the start at the bottom, go up 1, up 2, and then use those to make this 90-degree angle.
Cool. Okay.
Not perfect, but it works reasonably well.
It's close enough, yeah.
And you can also use Cassiopeia to point at Andromeda. So take the top 3 stars and make an arrow out of them, and they point right to Andromeda. That's about 1.5 fists, 1.5 fist diameters. Here's my fist at arm's length from the tip of the pointer. Now, what? Let's see. So some people wondered, what would our galaxy look like if we could leave the galaxy and turn and face and look at it from a distance? And so we talked about this in one of our earlier sessions. And astronomers think that the galaxy in the sky that most resembles us is NGC 6744. So let's see if we can find that one. NGC 6744. And it's not visible from Canada. It's in the southern hemisphere. So what we have to do is make the Earth transparent. And it's in this constellation called Pavo, which is a peacock.
Oh.
And if I zoom in on this galaxy, it looks like this. So this is another one of these spiral galaxies, very face on, close to face on to us, just a little bit of a tilt that makes it narrow left, right. And you can see that the core is not a circle, but it's elongated. It's we call that a barred, B-A-R-R-E-D, little bar in the center of the galaxy. So it's a barred spiral galaxy with the arms wrapping around it. And all of these little pink knots would be nebulas where stars are forming, like the Orion Nebula we talked about some months ago. So that's NGC 6744. If you ever go to the Southern Hemisphere, it's not a very dim galaxy. It's 8.25. So it's something that you could see in an amateur telescope. You just need to be at a part of the world that can look up and see the Southern Hemisphere.
A good goal for whenever we can travel again, or for anybody who's already in the Southern Hemisphere.
All right. Now, let's talk about asterisms. So what I'm going to do is I'm going to do F3. Let's go back to Antares here for a second.
There's just one question as well from someone asking if you'll be able to post the link with other stars from Star Trek. If you want to send that over to me at some point, I can just put it up in the YouTube description or on our website as well.
Let me just do that here.
Okay.
Do that. Just take a second to do that. Gmail. Compose to Jenna.
Thanks, Chris.
Okay.
And I'll send that out in the chat and in the YouTube comments as well. So that if folks are interested, they want to find out more about those stars in Star Trek, you can get to that.
Let me know if you've got that. All right, so this is kind of different. So we've talked about galaxies, we've talked about bright stars. I want to talk about asterisms. So asterisms are star patterns that are not constellations formally, but they make a shape in the sky. The Deneb, let me just get rid of the clutter here. So we've got Vega, Deneb, and Altair making that big summer triangle. That's called an asterism. The Big Dipper is called an asterism because the Big Dipper is part of a bigger constellation. But you can also have asterisms that are only visible in a telescope that you have to magnify. And so there's one that's called the Stargate. And I've seen it and it's cool.
Like Stargate from Stargate?
Yeah.
Oh, cool. Sorry, that was a very dumb question. But
it's a bit debatable. So let's see if we can figure this out. So let's see. This isn't the best time of year for it. So let me go back and see. When did I say we could see it? It's in Corvus. So we'll go back a couple months. And here we go.
There we go.
Oh, maybe I picked I got the wrong one. Let's try this one more time. HIP 61455. Is that the right one? All right, let me just turn this off so I can see if I can. Oh, that's not the right one.
Oh no.
Corvus. No, God, it's up in here, Corvus. Here, let me find it this way.
Is Corvus visible from Canada? Oh, wow.
Yeah. So let me do this, and I'll do Stargate Asterism. I just noted the wrong star name.
Oh, shoot. Sorry about that.
Okay. STF. Let's see if this works.
STF 1659.
Here we go. HIP 614661466. There we go.
Ah.
So when you zoom in on it, you get a shape, a triangle with stars in the middle. And if you zoom in, and again, going back to my markings. So there's a telescope at sort of low power. If you want to do a telescope at high power, it might be down more like something like that. So you get a little triangle of 3 stars inside a bigger triangle of 3 stars. So it's actually more like
I'm sorry, I don't know.
Flux capacitor from Back to the Future, right?
I watched that exactly once. I'm sorry.
Yeah, no, it's okay. Everyone else is screaming at the Zoom.
I'm sure they are. And you can tell I'm going red from embarrassment of not knowing my sci-fi.
No, it's okay. It's okay. Yeah, so if you have a go-to telescope, just make note of this star HIP 61466. And you can always do a screen cap and get the various designations of the stars. And you can slew your telescope to this spot in the sky, and you can pick up this little asterism that looks like a cute triangle and a triangle. Its nickname is the Stargate Asterism. And there are lots of asterisms in the sky. This one looks like a golf club, or like a putting.
Oh yeah.
There's all kinds of them all over the place. If you do a little exploring with your telescope, you could discover your own asterisms. There's the field is open for exploration and discovery.
That's the nice part about asterisms, is that since they're not official, you can kind of just make them up if you want to.
Now, speaking of flux capacitors, let's give one that everyone can see.
Yeah, this one's an easy one to find.
All right, so let's get rid of the circle in here. So back to our summer triangle. Let me just bring up my horizon again here. So I go back to, here we go, the end of June. So here's our sky tonight at 11 o'clock. And if you look at the big summer triangle of Vega, Deneb, and Altair, in the real sky, and let me see if I can turn off the constellations here for a second so we can really see this. You're going to notice that there's a little star that's prominent right in the middle. And this, in the real sky, it resembles, to me, it resembles the flux capacitor shape from Back to the Future. And so what's cool is that if you find the big triangle and then find that prominent star and zoom in on it with your telescope, that's Albireo. So it's the beak star of Cygnus the Swan. There's the swan. And in a telescope, it turns into this lovely two-color binary star, double star. Ooh. And I'm not going to tell the colors because I'd rather people discover them for themselves and render their opinion. But you'll see that it's two different sizes, sort of two different magnitudes, so they're different brightnesses, and two different colors, very distinctive in Albireo. And so I sort of call that the flux capacitor in the summer sky for people to pick up.
I'm gonna have to go back and watch Back to the Future again.
Now, let's talk Vega.
Sure.
So Vega is the brightest star in the summertime sky. One of the reasons it's so bright is that it's not very far away. It's only 25 light years from the sun. And it's actually the homeworld of the aliens that built the network used in the book and movie Contact.
Yes, a couple people have asked about that.
Yeah. So when Jodie Foster's character, based on Jill Tarter, we think, Ellie Arroway, I think her name is, travels in the craft and visits the network, and she speaks to the entities that built it. They tell her that they came from Vega.
Cool.
So everybody can go on up and easily find Vega and just let their imagination soar in the summertime about alien.
Cool.
Now, what I think is cool when I think about space and how vast it is and how far away things are, you can get a little sad on one sense because it would be so challenging for us ever to go anywhere else. You know, if we invent warp drive, then maybe we're there, but it's looking like a pretty tall order for now. And so even communicating with another civilization or another star would take years and years while we send and wait for replies, because at the speed of light, the signals have to travel for so long to get to these other stars. But wouldn't it be cool if you lived in a place where the other stars were only light weeks or light days away? Planets around another star could maybe communicate with you very easily. And one of the really cool things to think about is a globular cluster. So a globular star cluster. So Messier 13 in Hercules is located about, if I get this right, about 25,000 light years from the sun. But inside that cluster are hundreds and thousands, if not millions of stars, all crammed into a volume of space that's maybe a light year across or less than that. I'm not sure if this tells us the size. I can't remember off the top of my head the number of light years the globe of stars would be across. But in the core of this structure, if there are planets around those stars, they're going to be able to communicate in the order of days, weeks, months, because the stars are so near to one another.
Colleen has added that apparently it's 150 light years across.
Thank you. Thank you very much. Yeah, I didn't have time to write that down. So your night sky would be lit, right?
Oh, it'd be so bright.
The stars would be so close to you and so bright that your whole sky would be one dome of glittering diamonds the whole time. So the culture, the civilization that you'd create when you lived in a circumstance like that would be so alien to what we're used to. But just imagine.
Marie mentioned that apparently M4, which is another cluster, I believe it's a globular cluster too, contains an exoplanet somewhere in there. So that would be.
Yeah.
I mean,
So we're now building bigger and better telescopes that will allow us to study individual stars in these clusters and detect planets that they might have as well. So
I'd be really interested to see how that would work without all of the other things that are creating gravity in that area, how that would affect the orbits of the planets and stuff like that if there were planets there.
Well, imagine, so we think that comets come into the inner solar system because they're jostled by a gravitational disturbance at the outer edge of our solar system. Perhaps a passing star that's, as the stars sort of jiggle around inside our galaxy, they may trigger a domino effect that causes some of the Oort cloud members to fall in as become comets. So that would be happening constantly in a place where the stars were so close.
Oh man, that'd be an interesting life in an area like that.
Yeah, I mean, it's like so cool to study, to think about. You have to almost be an astrobiological philosopher to just conceive of how it would be different, right?
Yeah.
All right, so globular clusters. By the way, Messier 13 is visible in binoculars. It's even naked eye visible from a very dark site on a moonless night, but you can find it with your binoculars. You just want to find the keystone shape of Hercules and find the western side of the keystone, or the higher side, and go 2/3 of the way up and point with binoculars, and you're bound to find it as a gray fuzzy patch in the summertime sky. There's our friend Vega, not too far away. So it's in that same patch of sky. Look for the curl of stars, the Corona Borealis. So if you're midway between Vega and Corona Borealis, then you're in the right neighborhood for the keystone, and you'll find it without any trouble. By the way, in the early days of Seti, we actually beamed a radio message to M13.
Really?
Yeah, it was I don't know if I have Wikipedia up here. Let's see if I can find it. M13 Seti. Arecibo message. Here's what it looked like. It was a graphic.
Oh, we can't see it yet. Oh, there it is. Oh, cool.
Yeah. 1974. So we used the Arecibo dish in Puerto Rico, the second largest radio telescope. China has a bigger one now, and beamed this set of numbers that form this graphic to the core of M13. So 25,000 years to get there.
Yeah.
and then folks started saying, maybe we shouldn't be doing that, because maybe there's a stellar empire inside of that galaxy who are more advanced than we are.
Oh no.
And we don't want to tell them where we are necessarily.
Well, we've got 25,000 years, sorry. So that's our future humans problem.
Yeah, that's our
They'll let them deal with it.
So let's talk, talking about science fiction in general. what stars and star systems are commonly used in some of these book series, TV series, movies, and so on. And in many cases, they're looking for stars that are like the sun, that might have a planet like Earth around them. And so I did a little research and I worked out what are the kind of nearest sun-like stars to us. And not surprising, one of the ones that came up is Tau Ceti. So going back to the wintertime, back to that constellation of Cetus that had the planet Vulcan in it. Here we go. Here's the head of Cetus. We'll go back a couple hours. So in the wintertime, you can see it right after dinner. So there's Cetus, and let's look for Tau. And there it is down there on the stomach of the whale. So Tau Ceti, here we go. Let me pick up the main star. Yeah, so Tau Ceti is a double star in telescopes. It's magnitude 3.45, so it's a naked eye star, easy to see. It's only 11.9 light years away. And what's cool is that its spectral class is G8V. So our sun is spectral class G2V. And the spectral class system works O, B, A, F, G, K, M. And then between the two letters, you put a number to indicate how close to which letter you are. So G8 would be almost a K. So almost finished being a G and transitioning to K. Whereas our sun is closer, it's only G2, so it's closer to G.
Okay.
So that means that Tau Ceti, being about 12, 13 light years away, it's slightly cooler than our sun. We know that it has 4 exoplanets already. So we know that. And Tau Ceti has been the subject of stories by Robert Heinlein, Herbert, Larry Niven's Known Space series. It's the planet Plateau. It's also the star that the planet Heorot is orbiting in his book about Heorot's legacy. Cherry's Down Below Station series of books is set in Tau Ceti. Robert Sawyer, Canadian Robert Sawyer, his Starplex novel references Tau Ceti.
Wow.
Robinson's, Kim Stanley Robinson's book Aurora, which I'm just reading right now. It's a generation ship that's departed Earth and gone to colonize another star system. And that Tau Ceti is where they went in that book. The Halo game series, The Expanse talks about Tau Ceti.
When does the Expanse, sorry, hold on. Does the Expanse talk about Tau Ceti after the first book? Because if so,
I don't know.
want to hear about
I don't
it.
know.
Okay.
I just looked at, yeah, one of those sources. And the movie Barbarella talks about Tau Ceti. Yeah. Yeah.
So this is a prime choice as a possible alternative to living around our Earth.
Yeah, because it's a sun-like star.
Close.
It's not too far away. Yeah.
Okay.
Well, if somebody wants to see that. Now you have to wait until the spring or the winter to see that star yourself. Let's see what else you can. There's also a star back to neighboring Eridanus. So we talked about Eridanus and the star for Vulcan. We also have the star 82 Eridanus.
Well, while you find that, Elendria wanted to point out that Tau Ceti is also in and I'm going to get the Vorkosigan saga as well.
Yes. So here's a link. So what I'm going to suggest people do is go to Wikipedia and search stars and planetary systems in fiction. And then as you scroll down, each star has all the references used.
Wow.
So here's 40 Eridani. So here's Star Trek Vulcan. Here's Dune. Let's see what else we've got. And I could go on and on and on and on.
Wow.
It's hundreds of stars. If we go down to Tau, let's see.
Oh, Barnard star.
ST. So I'm just highlighting a few just to get people's appetites whetted. So here's Tau Ceti. So we have Star Trek. Let's see.
Apparently there's an entire article about Tau Ceti specifically.
Yeah, there's the article. Yeah. And here's I may not have the right one, but anyway, yeah, I did read an article earlier about.
I'll see if I can find it.
Yeah.
And send it out. That's so cool.
Yeah. So there's that one. Now back to the summertime. Let's go back to summertime and pick up a few that we can see now.
Wow, the list. I'll send it the link to Tau Ceti in fiction. It's huge. The list is huge for the number of pop culture things that have used Tau Ceti. That's insane.
So this star, 72 Hercules, it's 46.9 light years away. It's visible binoculars. It's one of the nearest sun-like stars, sun-like stars, so stars like our sun. Nearby in Draco, we have Sigma Draconis. That's down here in the neck of the dragon. It's a naked eye star. It's actually a double star. So I guess there's a couple of stars nearby, makes it a double star. It's only 18.8 light years away. It's a sun-like star. And so if there was a civilization on a planet, it would be an 18-year round, 18 times 2 round trip to communicate with them. And then 51 Pegasi. So let's go back to our friend 51 Pegasi.
18-year times 2, 36-year round trip is not that bad.
No, but we can do better. We'll do better in a couple minutes here. Yeah. All right, so 51 Pegasi. So if you come out after midnight, when the big square of Pegasus comes out that we talked about, if you look carefully at the western edge of the square, then you can find a fairly visible star. It's about midway along the edge, and it's a little offset outside the box. And you can see it with your unaided eyes. I've seen it many times. And that star's name is 51 Pegasi. It's 50 light years away, and it's the home of the first exoplanet ever confirmed by human beings.
Really?
So back in 1996, I believe it's 1996. I could have the numbers, the facts mixed up a little bit, but let's see if I can find it here.
It would have been around 1996 based on the charts that I've seen for exoplanets.
51 Peg exoplanet. So being the first planet to be discovered, let me see if I have it here. 1995, yeah. So being the first planet to be discovered around that star, it's got the letter B. So it's 51 Pegasi B is the name of the planet. Astronomers have since given it a more formal name, proper name. They call it Bellerophon.
Oh, that's in Firefly. Sorry.
Yeah, it could be. Yeah.
Yeah.
So Bellerophon in mythology was the first person to ride Pegasus.
Okay. Oh, yeah. Okay. Fine.
And that's
okay.
only fitting
that's
because
fair.
he's in the constellation of Pegasus.
That's good. That's a nice name.
So 51 Pegasi B is a hot Jupiter. It was discovered using, I believe, the transit method, or maybe it was let's see,
That might be radial velocity. I know radial velocity was earlier.
Yeah, radial velocity. So what they did is the hot Jupiter was massive enough that as it orbited the star, it tugged on the star, and the mutual center of gravity of the star and the heavy planet caused both of them to be offset from a central orbit. So the star wobbled, and they could use the star spectrum to detect the wobble and calculate what would be orbiting it, what would the mass of the object disturbing it. So that's the first discovery of exoplanets.
And the interesting thing about exoplanets too, I mean, you look at what Kepler found with radial velocity and with transits, I believe, well, at least definitely with transits, the planets have to be lined up exactly right with us from our viewing point, because otherwise, if you're looking for a planet to go in front of its star, make the star dim, and then come out the other side again. And if you're not exactly in line with the plane of that solar system, that star and planet system, then you won't see it. So it limits us to seeing very specific planets. And radial velocity is similar because you're measuring it when it's on like when the star's wobbling away and towards you. Whereas if it's turned sideways, it doesn't wobble away and towards you, it wobbles in a circle, and you wouldn't see the change, I don't think.
So if the whole solar system is tilted face onto you, then the wobble will be making the star change its location in space, not move closer and farther. So the spectrum won't change at all.
Yeah.
So you need Astrometrics, which is the measurement of positions, to see any variation in it.
Which would be very difficult because most of the stars are really far away and don't move that much.
So just because we've only discovered a few thousand planets in that patch that Kepler studied, that's because those are the ones that happen to be aligned face onto Earth.
So it means that it's extremely likely that many stars have planets around them. That I would even go as far as to say most stars have planets around them.
So when I was young, planets were science fiction. We weren't sure. We assumed, but we didn't know. And then in 1995, we discovered the first one. And now we've discovered them at such a pace that astronomers are now basically convinced that every star would have a planet, at least one. So
that's pretty cool.
It's so exciting. All the young astronomy enthusiasts that are just coming up and getting started, they have a whole universe of planets to now explore. You know, we've mapped the stars. We know where the stars are, but now we've got people that are going to come up and study all those little planets that are orbiting them. It's just amazing.
So cool.
All right, so let's we're winding down a little bit here. Let's cover a couple more things I just wanted to touch on.
And I want to touch on a couple things as well.
Go ahead.
I would like to touch on a couple things at the end as well.
So let me talk about what star is closest to the sun.
Yes.
Closest one would be easiest to travel to, for example. Most people would know it. They've heard of it. They may not realize why it's famous. There's a song in the Big Bang Theory. So what is it?
There's a song in the Big Bang Theory. Proxima Centauri is the nearest star. The celestial bodies that follow are.
Yeah. So let's actually find. So here we are in the southern sky. This is the sky tonight at midnight. And let's see if I can I'm just going to make the Earth disappear transparent here for a second. Let's see if I can pick it up. Can you see that? There's the constellation Centaurus. It's just below the horizon. All right. So we can't get it in Canada, but if you travel to the middle latitudes of the United States or further south, you can start seeing Centaurus. And so, or take your holiday once we're able to the southern hemisphere, Africa, Australia, New Zealand, South America. And there it is. So here we have this star called Rigel Cantorus. That's its proper name. Its Bayer designation is Alpha 1 Centaurus or Alpha Centauri. This is where the Robinsons were going in Lost in Space.
Ah.
That's where they were heading. Because this star is a triple star system. It's only, let's see, 4.37 light years away from us. Now, Rigel Cantorus is a double star. So if I zoom in, I should be able to get it to split. So there's the double star. So we have A and B. The A star is a G2V class.
Oh, that's just like us.
Same as the sun.
Yeah.
So it's about 1.1 solar masses. So it's 10% more massive than our sun, but it's swollen a little bit. It's about 20% more larger in radius than our sun.
Okay.
But it's only 4.37 light years away. It's so exciting. And there are planets around it. We've discovered already.
Are there?
Yeah.
Oh.
The B star down below here, its nickname is Ptolemy. So it's the same distance away, but it's a K star. It's a K1. So after G comes K. So it's a little bit warmer in color, a little bit, warmer, more towards the red end of the spectrum. It's 90% the mass of our sun, and it's 85% the size of our sun. So it's a little smaller. Okay. Then there's a third member of the party. Proxima is the C star. So this is B, and C. So the C star, I don't know if I can see it in Stellarium, but it's the closest of the three. So it's slightly less than 4.37, which makes it the very closest star to our sun that we're aware of. It's a M6V. It's a red dwarf star. So its magnitude, I think, I can't remember the magnitude. We could look it up, but
I'll check and take a look.
It's not a naked eye star. I'm not even sure it's a telescope star, but it's only 12% the mass of the sun. But I believe it also has an exoplanet, and it's the closest star to our solar system.
Its magnitude is 11.05.
If there were beings, intelligent beings around any of those three stars, we could communicate with them in 9 years there and back.
That's not bad.
So, someone could make their career being a Centaurian, dialogue person in their life. They could have. they could have 4 or 5 conversations in their life.
It'd be huge moments in your life. But on that note, so we sent messages to M13. Have we sent anything towards Centauri, the various Centauri stars?
Well, I'm not sure, but let's go there for a minute. So
Okay.
should we? So Stephen Hawking said we shouldn't.
Okay.
He's worried that if there's somebody out there that may not be benevolent, that maybe it's not a good idea to let us know. If you're familiar with the book, The Three-Body Problem, written by the Chinese author, one of the books in his series is called The Dark Forest. And he postulates that the reason we've not detected any other alien civilizations is because nobody's willing to put their hand up. Because they think that if anybody puts their hand up and waves and says, we're here, they get taken out. So the smartest thing to do would be to lay low and just listen rather than transmit.
Okay.
So that's a cool topic for another day.
That's interesting. Yeah. And I guess the other thing too is that if maybe we're listening for the wrong stuff, like we can listen in the way that we listen to the world and electromagnetic radiation pretty much. But perhaps that's not how. Anyway, this is getting into interesting topics of conversation. Maybe we're listening for the wrong stuff.
Well, there are theories where we can listen to the wavelength in the universe that is least affected by interstellar medium, which means that the signal would broadcast most efficiently. So that's what Seti did originally, was started listening at that particular band in the hydrogen spectrum. Some people think that if you had a good laser, you could point it accurately, you could just direct a laser beam at a planet near a star and communicate sort of one-on-one.
Pulses, yeah.
With a pulse. Then there's the gamma ray bursts that people wonder about.
Yeah.
What are those? Are they natural or are they artificial? So yeah, that's another time.
Yeah, that's a big long conversation.
So let me finish up with just a couple more things to say. The constellation Sagittarius here, the star Rookbat. Where's Rookbat? We can pop up. Maybe he's not in this picture. Rookbat. Oh, there he is. He's just below the horizon here. There's Rookbat. So Rookbat was the star system for the Dragon Riders of Pern series of books, which is, they're really good books.
For what books?
They're called the Dragon Riders of Pern.
Dragon Riders of Pern. Okay.
They're written by Lois McMaster Bujold, the same lady that wrote the Vorkosigan Saga books. Okay. So that's Rookbat. We talked about Tau Ceti, Altair, the star Altair. We talked about, I don't know if I mentioned that it was the star that the Forbidden Planet movie was going to. So the movie Forbidden Planet, they were going to Altair 4. Epsilon Eridani, so back into the wintertime where Vulcan is. The Epsilon Eridani was the star that Babylon 5 was orbiting. Okay. The spaceship. Yeah, yeah. And Zeta Reticuli, I don't know if I can see Zeta Reticuli. Reticuli. Okay, that's below the horizon for us. Down in the southern hemisphere. This is a double star. Oh. It was the scene for the Alien franchise.
Oh, cool.
Yeah.
Okay, those ones.
So that's all I had listed. We could go on and on and on. We have a few minutes for you to do a couple of other cool things and answer any questions.
I just wanted, so if everyone send in your questions now, because I don't have that much to talk about. But I wanted to mention that today is Asteroid Day, which is an internationally recognized day created by Brian May, to bring awareness to the ever-present threat of us potentially getting hit by space stuff, and how what we can do and trying to find innovative solutions to large asteroids coming our way, and potentially ending, life as we know it on Earth. Super fun and lighthearted topic, but I wanted to mention it because we're talking about sci-fi today, and there were a couple movies. I have seen neither of these. I know, Chris, you've seen them. or at least one of them, Armageddon and Deep Impact, both of which came out in 1998. Good year for asteroids hitting Earth, and discussed what would happen in that case. And it is an interesting problem to deal with, because if you have an asteroid coming towards Earth, you can't just blow it up, because then you get a whole bunch of smaller chunks continuing to head towards Earth. So I think in one, I don't know, I mean, I don't want to give spoilers, but that came out in 1998. So in one, they split it in two, and in one, they blow it into smaller pieces that burn up in the Earth's atmosphere.
Yeah, Deep Impact and Armageddon. So what was cool about Armageddon was the visuals in the movie made it seem like it was actually a comet, not an asteroid, right?
Right, okay.
And one of my favorite GIFs or GIFs is this one. Let me see if I can make this pop up. Let's see if I can make. So this is Comet 67P Churyumov-Gerasimenko. And this was the Philae lander.
Oh.
So the Rosetta mission and the Philae lander caught this video, and it looks like it's snowing.
That's so
because
cool.
It's all the gas and dust coming out of the active comet.
Wow, so that would be the sort of thing that the people from these movies would see if they got up close to the comet to try to blow it up.
If they had to blow up a comet, that's what they get. Yeah.
That's
so I thought that was cool.
That's super neat. So if you're looking for things to watch tonight or in the next couple of nights, check out Deep Impact and Armageddon, which is what I'm going to be doing.
Or Forbidden Planet.
Or Forbidden Planet, sorry. And also Phil's suggesting reading Lucifer's Hammer, which is apparently better than either of them. So we got lots of options for all of you space nerds out there.
Yeah.
And then I also wanted to tip my hat, mostly because we haven't talked about the Expanse much, but I really like the Expanse because, and there are a few things that you can see in the night sky from the Expanse, including Ceres, which I'm going to bring up in our other series, which is, oh, it sounds similar. Anyway, our other program called Explore the Universe, where we're doing an observing program. And that's on Thursdays, every other Thursday, alternating with this one. I'm going to bring up when Ceres is at Ceres, it's not a minor planet because it's oblong shaped, right? So it's like it's just an asteroid belt object.
It's a minor planet, yeah.
Okay.
It wouldn't be. It's not a dwarf planet, but it's a minor planet.
And Eros is also a minor planet, or is it just okay?
It's a minor planet as well. Yeah, they're all minor planets unless they're spherical. Then they're a dwarf planet. If they're
okay, I see. Okay. So yes, Ceres is at an opposition on August 28th. So if you're looking to see Ceres, that is a good day to see it.
So what I'm going to do here is I'm going to show you. Here. This is Starry Night. What's cool about Starry Night is, I'm just going to bring this to, I'm going to travel us through space. So, okay, I can't do that one. Let's do Alpha, I think I can do that one. So I'm going to fly us to Alpha Centauri. Let's see. No, Alpha Centauri. Okay,
so Alendria has just brought to my attention that Ceres is actually a dwarf planet because it is spherical. It's Eros.
Yeah, Ceres is, yes.
Okay. Yes. Also, I just sent out a link provided by her about Ceres if you're interested.
So one of the things that I think is funny is that in sci-fi, a lot of characters refer to places in the universe using constellations that were created by humans on Earth.
And the stars sorry, yeah.
Yeah. So the funny thing is that the constellations are only valid for Earth, basically.
Yeah.
When you get into the universe, they're not valid anymore. So what I thought I'd do is I'd like to fly us from home to Alpha Centauri and look at the constellations from there.
Perfect.
So here we go. So we're going to lift off the Earth here.
We had a question just like this in the comments, so this is perfect.
Hope everybody can see this. So we're going to fly, leave the solar system, and head. Now watch, the constellations will start changing shape a little bit as we get farther from home.
Oh, yeah.
See some of them are changing shape a little bit.
Oh, that's strange.
And the ones that are closest are, okay, here we go. Oh. So now we're in orbit around Alpha Centauri. And what I thought I'd do is look for Orion. Let's see if I can put center Orion in the view. So here's how the constellation of Orion would look
Whoa. Sorry.
from only 4 light years away from Earth. So Orion is still doing its thing pretty well.
Yeah.
Gemini is all messed up. Here's Taurus. You can see Taurus has changed a little bit. Let's find the Big Dipper. The Big Dipper looks the same because the stars of the Big Dipper are all about 80 light years from Earth. Almost all, give or take, a couple of light years are the same. We think that many of the stars of the Big Dipper are from the same family, of the same cluster, the same siblings.
Mm-hmm.
So you need to go farther away in order to see the change. So let's try, that's 4 light years. Let's try Sirius.
I was going to say the Ursa, or no, sorry, Canis Major looks all weird. Sirius is now up near Orion.
So I'm going to go to Sirius and see how the constellations change from 9 light years from the sun.
Okay, here we go.
How's our time? We got a couple minutes.
We got a few minutes, yeah. This is super neat. This is Starry Night. You said, whoa.
See how they're changing? So the stars that are closest to the Earth are part of the same constellations, but the ones that are close to us change their position because of parallax.
Woohoo.
So now here we are at Sirius, and there's Orion. So Orion stars are farther again, so they're not really affected. Here's Leo. You can see Leo has changed a little bit. Let's just pull a little bit further away here so we can see.
And that one star that is like the start of Orion's arm being held out is way out of place.
Yeah. So that's whoops, get this right. Yeah. Where's our Dipper? So now our Dipper is changing a little bit.
A little wobbly.
Oh,
Boötes or booties, whatever you want to pronounce it, looks a little funky.
Yeah. So Arcturus is a bright star because it's close to the Earth, relatively speaking. It's only distance is, do I have it on here?
I don't see it.
41 light years.
Okay.
So over centuries, millennia, Arcturus will have what's called a high proper motion, which will move it across the sky, and it'll actually change its shape. So it'll change the shape of the constellation.
Oh, wow.
Over time. Yeah. So, and there's Hercules. Remember, the keystone of Hercules is now all warped.
It's hard to recognize any of these except for Cygnus.
There's Vega. So here's Deneb, Vega, and there's Antares. So we've got our summer triangle still. So it just gives you an idea that you don't have to travel far from Earth for everything to change. And what I'm going to do is I'm going to just drop this into the nighttime sky. Actually, what I'll do is I'm going to take us to the sun and see if I have a favorite here set up. I can show you the orbits of the asteroids if I have one here.
No. Phil pointed out to check out the Little Dipper as well, and I actually honestly didn't even recognize the Little Dipper. It was like triangular shaped instead.
Okay. So what I'm going to do is I'm going to view us from the surface of the sun. And I'm going to drop a pin on that's fine. Let's do North Pole of the sun. Let's see if I can get there fast. So now we're sitting on the sun. And as we lift away from the sun, I think I can get the planets. View from, let's see, hovering over the sun. There we go. This is what I want. So now we're above the sun. I'm going to turn off the constellations. I'm going to turn on the planets here. And I'm going to draw you the orbits.
Ooh.
So Mars, Venus. There we go. Just move you and I over here and do this. So this way we can look at the expanse.
Yes.
Here, so let's draw Mars's orbit.
If you haven't read The Expanse yet or watched the series, I recommend reading the books before watching the series, but it's near future sci-fi. So it is all within our solar system. And it's a really fascinating interaction between the two powers, which are Earth and Mars. And then the third, which is sort of like almost like the rebels, the Belters. It's absolutely fascinating, and it's relatively accurate as things go. And yeah, there's no faster than light travel. There is a fictional drive called the Epstein drive, which allows for traveling at high speeds essentially that we don't have. But other than that, it's really great. It's very accurate, and yeah, in orbital mechanics matter. It's a great series. I definitely recommend.
All right, so I should be able to pick up, where is the Eros, or series? I'll do it this way.
It's not there.
It's in a different, it's in its own class. So let me just pick up their series. So its orbit should be there, and Eros, I can pick up Eros and draw its orbit as well. So I don't know if you can tell, but.
Okay, Eros is a little wobblier.
Yeah.
Actually, they're both pretty wobbly.
So yeah, Eros's orbit.
Oh, they're Ceres, yeah.
It's offset. Yeah, it's very more elliptical, and Ceres is the red one.
Eros comes pretty. Does it come close to Earth, or is that just a tilt that?
Earth's orbit is Earth's orbit is here, the green one.
Yeah.
So Eros would be considered a near Earth asteroid.
Okay.
But Ceres is out there between Mars and Jupiter in the main belt.
Okay.
And if I do 67p.
Hold on, you got a slash at the end of it.
Let me just do 67p. Let's see if that'll work. Here we go. Just to show you the difference. So there's the 67p's comet orbit is like that. And if I do Halley, you'll see that Halley's comet is very elliptical. So Halley's comet goes closer than Venus and out to nearly to Saturn.
Wow.
So there's some interplanetary traveling for everybody to do. I think that's a pretty good overview of the topic, and I hope everybody's inspired to link science fiction with astronomy. Head outside, look up. We haven't talked about planets and the moon, and
Yeah.
we can do that another time.
We haven't talked that much about like the within the solar system sort of side of things, because there's some really good sci-fi that's just within the solar system too.
Yeah. So one of these days we'll do planetary exploration in reality and in fiction. How's that?
That sounds great. We'll figure it out another time. All of you who are joining, consider writing your own short stories inspired by your observing, if you so choose. I feel like there's some really cool stuff that we could come up with. And question from Douglas, will we post all of the links? They're all on the YouTube page, so I'll make sure that they go on the YouTube or in the description of this YouTube video once we're done. So all the links will be on YouTube. As always, you can watch it again on YouTube anytime. Our channel is RAS Canada, RAS Canada. And our next offering, for those of you who are interested, on Thursday, Krista Van Leerhoven is joining us to talk about moons in the solar system. So if you're interested in this stuff, she is both has her PhD and is currently a teaching candidate. So she's great at talking about this stuff. It's going to be on our YouTube channel, and you can register on our website as well. Okay, I think that's all I got for now. Chris, do you have anything else you want to add?
It's been fun.
It has been fun. I like this topic. This is super fun.
All right, everybody. Keep looking up, everybody.
We'll see you guys in 2 weeks. We're doing this every 2 weeks now. So we'll see you in 2 weeks. If you want, you can join us for Explore the Universe, which is happening next week if you want to try your hand at observing. Chris, we'll see you in a while. It'll be longer than usual.
Couple weeks.
We'll see you then. And
but you guys know where to find me if you need me.
Exactly. Yeah. We've also got Chris's blog. He's going to post about all sorts of stuff, regardless of whether or not you're joining us.
Yeah. And all those observing suggestions I gave, they're posted now on the Sky News website.
Awesome.
So monthly planet roundup, as well as the weekly what's happening in the sky, I'm putting up there with Alendria. So
fantastic. Okay, so that's up on Sky News. Check that out, skynews.ca, and we will see you guys in 2 weeks. Thanks everybody for joining.
bye.
Keep on reading your sci-fi, and we'll see you next time.
Bye.
Bye-bye.